Hello there, 901, Mr. Herman here. This exercise right here is exercise 3D, rationalizing the denominator. The learning goals for this exercise is to understand that a surd multiplied by itself gives a whole number, and to understand what rationalizing a denominator entails. The success criteria for this one is to be able to rationalize the denominator of a surd fraction. Now this will be the only video tutorial that you will need to see for this week, because the rest of the lessons will be looking at exam revision. Exercise 3D is the last exercise from the surd topic. For this video, just picture this as the whiteboard, and you'll go ahead and open up your exercise books and write down the notes that you see on the screen. At any time, you're more than welcome to pause the video to get the notes down, or even rewind if you didn't quite understand a certain concept. So right now, this is rationalizing the denominator as the title, and today's date is the 31st of the 5th, 2021. Now bear in mind that I'm recording this on the Sunday night, and hopefully this will be readily available to you for the Monday morning. So rationalizing the denominator, before we get into this topic, we've looked into different surd properties, how to simplify surds, how to add and subtract like term surds. This right here is going to be a fairly new concept. And if you're pretty strong with the idea of how surds work, then this exercise should be a walk in the park. So as you know, it is easier to add or subtract fractions when the fractions are expressed with the same denominator. So in a similar way, it is easier to work with surds such as 1 over square root of 2 and square root of 3 minus 1 over the square root of 5 when they are expressed using a whole number in the denominator. This process that removes a surd from the denominator is called rationalizing the denominator, because the denominator is being converted from an irrational number to a rational number. In other words, this 1 over the square root of 2 that we can see here can be written as another number where this denominator is a whole number. And it's just strictly the denominator. The numerator over here, this can be any number. So it can be a whole number, it could be a surd, it doesn't matter about the numerator. But the denominator must be written as a whole number. So we have to multiply this or manipulate it in such a way that it's still going to equate to the same thing, but the denominator is a whole number. So rationalizing the denominator involves multiplying by a number that is equivalent to 1, because remember, you can multiply anything by 1, which will still make the answer the same if you multiply it by 1. But this fact here, we can manipulate this thing that we're multiplying by 1. We can make this look like anything we want to, provided that it still equals 1. And when we do this, this changes the denominator to a whole number. Now the rule that I use to make sure that this works, this rule here, it's a general rule. Say for instance, you were to have some number x over the square root of y. Now remember that x and y are obviously going to be numbers, and these coefficients, or these letters rather, will be replaced by numbers. What we do is we take this and we multiply it. Now obviously we can just multiply it by 1 and we'll leave us back to the same thing. I want to multiply it by something that still equates to 1, but we'll also get rid of the square root of y. And what we do is as follows. So what we're doing is we're multiplying by whatever the square root of y is this will be multiplied by that as the numerator and also the denominator. And we're doing two things. The first thing is this square root over y over square root over y. No matter what y is, this will equate to 1 when actually worked out. Because technically they cancel each other out and becomes 1 over 1, which is 1. So this ticks off this criteria here. But the second thing, and the more important thing, is you've got to remember the square root of y multiplied by the square root of y. Well, this will just be y. So remember how we went through different examples. If it was the square root of 5 times the square root of 5, this is the square root of 25, which is in fact 5. So we start and end with whatever y is, 5, 5, 25, and you can apply this to every single number. You will always return back to the same number that you multiplied by. And we're going to use this fact to manipulate this expression over here. And what will this turn into? This is x times the square root of y, which is x square root of y on the top. And square root of y times square root of y turns into y. So this, what we started off with, and I'll change this color here. What we started off with and what we ended with are two completely different looking things. But when you replace, at the end of the day, when you replace these letters with numbers, x with a certain number and y with a certain number, they actually equate to the same thing. Okay, so this rationalizing the denominator, this right here is what we're applying. This is rationalizing the denominator. We're going to go ahead and do 4 examples just so you can see how this works. So the first one, we're going to rationalize 2 over square root of 3. So 2 over the square root of 3. So all we need to do is we need to multiply this by whatever the denominator is. There's a numerator and a denominator. What this turns into is 2 times the square root of 3, which is just 2 root 3. And the square root of 3 times the square root of 3, which just gives me 3. Because, just to put as a side note, and you don't have to write this down, the square root of 3 multiplied by the square root of 3 is equal to the square root of 9, which is 3. So we ended up with a 3, and the whole point of us doing this is to make sure that we don't have a square root symbol on the bottom of our fraction. And we've checked that criteria. The second example, this right here, is 3 square root of 2 over the square root of 5. Now, because there's already a 3 in front of the square root of 2, this makes no difference to what we're going to multiply this by. All we care about is that denominator. And all we need to do is multiply it by square root of 5, the square root of 5. 3 times the square root of 2 times the square root of 5. Hopefully by now you should know that you can just do this all in one step. This is the square root of 10. And square root of 2 times square root of 5. You can put these two together under the same square root, multiply the 2 and the 5 to get the 10. And the square root of 5 times the square root of 5 just returns back to 5. If you were to simplify any further between the whole number numerator and the whole number denominator, you'll go ahead. And if you were to simplify whatever is in the square root, you go ahead and do this. At this point, this is at its simplest form, so you can't simplify this any further. This will be your final answer. The last 2 examples, we're going to look into simplifying or rationalizing the denominator rather. 2 over root 7 over 5 over root 2. Now, a lot of students get confused when they see the denominator also has a whole number attached to this. This makes no difference as to what you're multiplying. As long as you just look at the denominator and namely the third part of the denominator, this will be root 2 over root 2. So don't add a 5 in front of it. Technically you can do that if you wish to. It's just going to involve more numbers to multiply with. So you're better off just doing root 2 over root 2, or whatever the denominator surd is. In this case, we have 2 times root 7 times root 2. This will give me 2 root 14, as 7 times 2 is 14. And this line here, we have 5 times root 2 times root 2. Now we know that root 2 times root 2 gives me 2, as the square root of 4 is 2. And this will be 5 times 2, which is 10. Okay, so I've skipped not a lot of steps, but just a few steps here. So remember, 5 times root 2 times root 2 gives me 5 times 2. Okay. If you want a little side note, just in case you got a bit lost there, this whole line here, let's just keep it as red. There we go. This line here is just 5 times 2, which gives me the 10. Now at this point here, we can simplify this even further, because we know that the highest common factor between 2 and 10 is 2. 2 goes into 2 once, and 2 goes into 10 5 times. So our final solution is root 14 all over 10. There is no square numbers. That is a factor of 14, so this can't be simplified any further. The last example, we have 1 minus square root of 3 over the square root of 3. Now this is the trickiest type example that you will get, because there will be the distributive law that we need to remember. That is A times whatever B minus C is. And remember, distributive law means that this is going to be A times B minus A times C. This is just a general rule that I'm going to apply when it comes to this, and you'll see why in a second. Now for now, we know that we are multiplying this by root 3 over root 3, just so we can rationalize this denominator. Now, the only problem we run into is we've now got this term that has this minus in front of it, and we have this as a times. So how you would actually technically write this is root 3 multiplied by 1 minus root 3. Because remember, it's this whole term multiplied by this root 3. And when we do this, I just put the root 3 in the front. It makes no difference how it's times. It could be that times that, or this times that. It doesn't matter. But I've purposely put it in this format so I can use the distributive law to expand this out. While simultaneously knowing that the root 3 times the root 3 just gives me 3. Okay, now we can go ahead and distribute this square root of 3 out. We've already rationalized the denominator, which is awesome. You will go ahead and expand this out. The square root of 3 times 1 is just the square root of 3. And the square root of 3 multiplied the square root of 3 gives me 3. Making sure that you remember there is a minus in the middle. This is all over 3. Now, there are so many 3's going on. It's easy to think that this can be simplified even further. What I don't want to see, it's not square root of 1 minus 1 over 1, because these 3's just simplify. This is incorrect. This is a no. Don't do this, okay? Keep it as this. Because of the fact that there is a minus there, this can't be simplified any further. Unless you can take 3 out as a common factor between these two terms to simplify with that 3, you can do that. But in this case, you cannot. So this will remain your final solution. And that is the end of this video for rationalizing the denominator. I'll go ahead and grab the questions out. Now this is just taken from my log sheet that I print out for you, which is on Microsoft Excel, but what you should care about, you should have a copy of this anyways, what you should care about is Rationalising the Denominator, exercise 3D, questions 2, 3, 4, 5, 6, and 12 is set as an extension question. If you see a little asterisk next to the question, that just means that I want you to attempt every second question starting with A. If you have any questions regarding this at work, you can always send me a chat on Microsoft Teams, or alternatively send me an email via the email that I sent within the first video of what to expect for the rest of this week. All right, best of luck, and I will see you soon. Bye.